So like with mirrors, with lenses, we want to be able to predict where the image of an object being, you know, put in front of a lens where it would appear. So the formula is actually the same as the mirror formula. 1 over the object plus 1 over the image equals 1 over the focus. And we need to note that for a convex lens, the focal length is positive and the focal length is negative for a concave lens. So meaning that if my object is, say, right here, and here is my convex lens, then the focus is somewhere in front. Maybe right here would be the focus, or right here. So it's somewhere in front of the mirror. And for the convex, or mirror, I meant lens, and for the convex lens, if our object is right here, so this is convex, and this is concave. So for the concave lens, it's negative, meaning that it is then behind the lens somewhere. Okay, so this would be our negative, and this would be a positive value for the focus. Now, in each case, we should be able to view the object on the other side, and we could flip around the lenses and have a different effect, but we're assuming that it's on the side that is convex and the side that is concave. Okay, so magnification actually is also going to work the same as for a mirror. So negative image distance over object distance will give us our magnification for our lens. Okay, so let's say we have a concave lens with a focal length of negative 32 centimeters, so somewhere over here, and we want to find the image distance and magnification if the object is 23 centimeters in front of the lens. So this is 23, and this is our negative 32. So it's 1 over our object plus 1 over our image. It's going to equal 1 over our focus. So 1 over object, 1 over 23. We could switch to meters, but it's not necessary. So we'll just leave that. And 1 over negative 32. And I'll just go ahead and subtract the 1 over 23. And that's going to give me 1 over our image distance. And then we'll just basically put this into the calculator. So just give me a second while I do that. We do want to be careful of our signs. And I do get negative 55 over 736, which we would then flip around. But it's probably likely that your calculator is going to give you a decimal. So I'll give you the decimal version of that. So negative 0.0747. So we would flip this around. So to flip it around, we would do 1 divided by this answer. So 1 divided by that. And that gives me our final image distance is going to be negative 13.38, so about negative 13.4 centimeters. So what does that mean? Our image is somewhere over here on the other side of the lens. Okay, it then asks for magnification. So magnification is going to equal negative image distance over object distance. And I just want to make sure I got that in the right order. Yep. So that will be 13.4 over 23. So we'll put that in. And we get 0.58. So what's that mean? Our object is 58% of the size of the original object. Okay, so next one, if we're 40 centimeters in front of that lens, so we're going to have 1 over 40 plus 1 over our image is 1 over negative 32, and we'll subtract 1 over 40. And that gives us 1 over our image. So we'll go ahead and do this subtraction. So I'm typing that in. And we get negative 0.05625. And we'll flip that around. So in order to flip it around, we do 1 divided by that. So our image is going to be negative 17.8. So again, on the other side of the mirror, I mean lens. All right, and our magnification is going to be negative image distance, so 17.8 over the object distance, that was 40. And we get 0.45 after rounding, 0.45 for our magnification. So it's 45% of the original object size. And it also appeared further behind the mirror than did the other one. So as we went further away, the image got smaller and appeared to be further away on the other side. Okay, let's go on to the next example. So now we're going to have a convex lens with a focal length of 15, and we'll have an object in front of it. And we want to find the image distance and magnification. So 1 over 20 plus 1 over our image is going to equal 1 over 15 right here. We'll subtract the 1 over 20. So we have 1 over image. So 1 over 15 minus 1 over 20. We get 1 over 60, which is 0.0167 after rounding. And again, we'll flip that. So 1 divided by 0.10, or 1 divided by 0.0167. We have to flip it around because it's the reciprocal. So we have 60. So it actually appears, our image is going to appear somewhere over here. So let's see. We want a magnification now. So the magnification is negative image distance over object distance. So negative 60 over 20. So negative 3 is our magnification. Okay, so that would also mean flipped upside down. Probably. I think that's the case anyway. Okay, this one, 1 over 10 plus 1 over image is going to equal 1 over 15. So subtract the 1 over 10. So 1 over 15, subtract 1 over 10. My calculator cooperates. That'll help, certainly. We get negative 1 over 30, which as a decimal is negative 0.03 repeated. So our image is going to be the reciprocal of that. And we get negative 30. Okay, so that would be our image distance. So now we're appearing behind the lens. And our magnification then is going to be 30 over our object distance, which was 10. So this time a positive 3. An image is formed 12 centimeters to the left of a lens, so with a focal length of, and that's minus 23, so our focal length is behind the lens, so we know we are concave. Okay, so negative 23 right here. Or yeah. We have an image at 12, so our image is somewhere over here to the left of the lens. Where's the object? So it basically works the same. So we have 1 over object distance plus 1 over image distance equals 1 over our focal length. So we have 1 over negative 23. 1 over our image distance is what we actually know that is 12, and we want to know our object distance, so we'll subtract the 1 over 12. Okay, so we'll go ahead and we'll put that in. And we get in the very end negative 7.8. 885. So after rounding, negative 7.89. So that means our object was on the other side. That is crazy. So there might be a mistake in here somewhere. So our object is actually placed on the other side of the lens in this case. Okay. When an object is placed 32 centimeters to the left of a lens, the image formed is 17 meters to the right of the lens. Okay, so we are going to have our lens. Here's our lens. And we're 32 centimeters to the left. Okay. Computer stuttered there for a second. So 32 centimeters right here. And the image formed is, so this is our object, and is 17 centimeters to the right of the lens, which means we'll say negative because it's behind it, and we're looking for the focal length. So we're going to have 1 over object distance plus 1 over image distance equals 1 over our focal length. So 1 over 32 plus 1 over negative 17 equals 1 over f. And we'll just plug that in, 1 over 32. And we get, as our final answer, because we do have the whole reciprocal thing going on, negative 36.3 is our focal length. So it is a concave mirror with a focus on the right-hand side. And we have some applications for lenses for vision correction.